And welcome back, and hopefully by now you have had the opportunity to ask any questions that you need to and get stuff answered on solving multi-step equations, because today we're moving forward with solving multi-step equations that have fractions and decimals. So we're going to start off with fractions, and this first problem that we've got here is x over 2 minus 1/3 equals 3/4. Now, there are two methods for which you can go ahead about solving these. The first step, though, for either method you use is to find the least common denominator. In the case of 2, 3, and 4, our least common denominator, or LCD as I will refer to it from here on out, happens to be 12. Because 2 goes into 12, 3 goes into 12, and 4 goes into 12. Now from here, I'm going to show you both methods with this example. So we're going to start off, I'm going to make a dividing bar so we can divide it out nicely so we know which side we're referring to. So the first method that we're going to look at is what's listed here under A, to multiply by the LCD using the golden rule. And what we mean by this is we're actually going to clear the denominator out. So by clearing this denominator, I'm going to take my x over 2, and I'm going to multiply this by 12, and I'm going to put it as 12 over 1 to help me out, minus 1/3 times 12 over 1 equal to 3/4, and I'm going to move my line over a little bit so I have room, times 12 over 1. Now when I do this, I can go ahead and start simplifying. So I see that 12 and 2 have this common factor of 2. So 2 turns into 1 when I divide by 2, and 12 divided by 2 is 6, which then if I look there, 6 times x is 6x, because 1 times 1 is 1, and we don't need 1's in the denominator if that's all there is. So then I have a minus sign. I see that 3 and 12 can both be divided by 3. 3 divided by 3 is 1, 12 divided by 3 is 4. So now I have 1 times 1 in the denominator again, which is the whole goal of clearing the denominator. So 4 times 1 is 4. Then finally I go over to the other side of the equal sign, and I see that I have 4 and 12 with a common factor of 4. 4 divided by 4 is 1, 12 divided by 4 is 3, and then 3 times 3 gives me 9. Now I have a much nicer fraction to look at. And so now this is where I go into the process of step 3 using order of operations backward to determine which operation to undo first, and then obviously simplifying and repeating those steps. So now this looks like a problem that we've done before. So I'm going to go ahead, and we were talking yesterday about how my plan of attack here would be to multiply by 6 and then subtract 4 to build the equation. So we're going to do that U-turn, and I'm going to actually undo subtracting 4 by adding 4, and then undo multiplying by 6 by dividing by 6. So when I go ahead and do that, I will add 4, and that gives me 6x equal to 13. Now I'm going to move my line over a little bit more so I have a little bit more space. I'm going to divide both sides by 6, which results in x, because the 6's cancel, equal to, and 6 doesn't go into 13, ooh, so it goes in twice, and then with that we have left over 1/6. So 2 and 1/6 would be my response. Now I'm going to go ahead and get rid of this because I obviously didn't have the room for it. So what I'm going to do is, on the next example, I will show you exactly how the other method operates, and then you can choose between the two. So to summarize, you find the least common denominator, and you either, and this method, which is what we did first, we multiplied by the least common denominator using the golden rule, and that clears the denominator. So I put denom for denominator. You can also change the equivalent fractions using the LCD and solve that way. And then using order of operations backwards to determine which operation to undo first. Using that golden rule to cancel the operation, which is what we did after we simplified, and then repeating as needed. So right now, you should go ahead and look at the next example, see if you can do it using this method, and then be prepared in the next video to go ahead and operate using the other method.